not diesel. Diesel doesn't produce enough power. You'd be talking milliwatts, not watts. We're talking order of magnitude more power.
Thank you. Next we have Brad Lindsay. It's a local company. And last but not least, after this presentation, since we are a little ahead, Bill and I decided that we open the forum for some general discussion. So please stay around if you can after this presentation. Right?
Thank you. I thank Mike Stinson, ASU, and members of the military for showing interest in what we're looking to offer. I'm a local company. I've been in business for 32 years. We focus on energy conservation. My background extends from HVAC into solar, energy conservation, energy management, solar daylighting, solar products, solar cooking, a variety of ranges of anything I have to do to reduce power is the interest of myself and my associates. Been blessed to have some really creative people working with me along the years, and able to build structures that are phenomenally efficient, and helping me develop products using inputs, spectroscopy, and other methods to move forward. One of the things I want to start with, here we go. We hear about comfort. When you boil energy conservation down to the bottom of the pot, it comes down to human comfort. I heard yesterday that 47% of the fuel that they spent in Afghanistan was for human comfort. If you focus on what makes human beings comfortable, you wind up with the movement of heat, basically, and what kind of heat makes people uncomfortable or uncomfortable. For problems we're looking at with this is going up on auto. Can you back it up a little bit, please? One more. Do it manually, but yeah. This shows what we've been doing with houses. It's kind of a slide left over from a city presentation, but it shows what's wrong with this picture. We have an igloo on a beach and palapas on a tundra. We've been told that insulation works to keep buildings comfortable, keep us comfortable. Insulation is designed and utilized to keep heat in the building. Many of us are wearing jackets today to keep the dry heat in. We wouldn't be wearing these jackets in August here in Vegas, we'd be dying. This is not what they do. So you can't take a blanket approach to building energy conservation into a building without using one product. You have to look at it and be climate specific. One of the things you have to look at when you're building in any environment, be it frigid, tropical, desert, it's got to be specific to that environment, otherwise you're just wasting massive amounts of fuel, which is what we notice locally in buildings here in the desert. My background goes from the frigid northwest of Midwest, I should say, of Michigan. We have office in the Caribbean. We've been dealing now with the state of Hawaii, helping them change codes and how they build their buildings. And what we're seeing here is technology that we've created, ability to significantly reduce the amount of energy used for keeping comfortable in building, be it a portable building, permanent building, or a movable structure. Next slide, please. How to keep comfortable in a remote location. We've been building structures for the last 8 years that are very portable sources for clean water. We have a device now that pulls water out of the air. And moving the effort to move a 55-gallon drum of water versus 55-gallon drum of fuel oil is the same amount of energy spent because the weight equals the same. And I also heard yesterday that the amount of water used in Afghanistan is equal to or greater than the amount of fuel that's used. So creating water, or finding water, getting water is a major concern. One of the applications we have is a water-to-air converter. It runs on 1,500 watts of power, pulls water right out of the air, drinkable distilled water, so you can use it for showering, drinking, cooking, at the point of your, especially on a forward outpost where getting supplies out there is going to be an issue. 1,500 watts is a lot of power, and now with the now available 500 watt per panel PV systems, to run water to air generator, air to water generator. It's a small system. It weighs about 200 pounds. There's a mock-up up here in the parking lot, and also a picture of it out there. Again, it's if you notice air conditioners walking by an air conditioner, see the condensate running out of the unit, you'll notice it. It's condensing water as it's producing cold air. The purpose of the machine is to produce cold air. The purpose of our machine is not to produce cold air, but it is a byproduct of the machine. But the purpose is to produce condensed water right out of the air, depending on where it is. You can range from 25 to 40 gallons a day on a 24-hour period, or half that solar power system.
Sir, how low humidity can you pull the water out of the air?
At 15-20% humidity, you're looking at 25 to 40 gallons a day in a 24-hour period.
But I mean, can you pull it out? I mean, Afghanistan has lower humidity than 15%. Can you pull it out of the air?
You pull water out of any air. It depends on if you need more water, you just double up or make the system larger. It's a very, very simple system. Technology's been around for many decades, and it's just a way that we develop the system and how fast the air goes through, which gives the water comes out of it. It's amazing that they won awards when it first came out, and due to some unforeseen problems with the economy, this technology was not lost, but temporarily not available. So we're in the process of manufacturing it again with the original inventor. So we have problems we have of cooking food without fuel. There was a 10-foot solar dish out there yesterday. We cooked a couple of chickens in it. It's spotty sky, so if you've got sunshine all day long, cooking meat without power is something we've been doing for many, many years. One of the products we carry is called thermal control membrane. Next slide, please. This is a solar cooking dish. Next slide, please. This is some temporary shelters we built in the past. Very, very portable. This is a 33-foot pressurized HEPO supplied air teepee. Two men can deploy it in a matter of minutes. Once it's buried on the outside, it withstands 50-mile-an-hour winds. This product right here in the back, this can be developed for under $400 and six people comfortably. Again, these were conditioned by a solar-powered heat pump that we created that runs again on 1,500 watts of power. So these are this is high desert applications, and we have power, water, and food without all solar power. It's completely standalone. Next one, please. This is solar powered shower. I heard yesterday that there's a great reduction in water usage from 8 gallons per minute shower head down to 2.5 minute shower head. And I have a shower system out there now on display. It's running on 75 watts of power. And we're talking about quarts of water per person rather than gallons per minute. We have 7 people taking a shower, full shower, fully sudsed up, fully showered out, fully clean, with 2.5 gallons of water for 7 people. That's a complete shower. That's all solar powered. There's no more uses than that. It's actually phenomenal how the way it works. And with that kind of water usage, your need to move the water to the front is diminished. The 150-pound pressure pump here puts out a mist that completely wets you within seconds. You turn it off, suds up, turn it on, and you're completely clean within a couple of minutes. So your gray water waste goes down, your water usage goes down. A lot of benefits with that. Next slide, please. This is the solar powered that I saw yesterday. A couple of Mitsubishi units that were running on some of the barracks, be it a tent or a building. This is a small unit. This is 1.5 ton. Puts out warm air and puts out cool air at the same. It's a heat pump, so it heats and cools. Since it runs off the solar, there's a variety of ways you can do this. You can take it off a mini grid that we saw here earlier. You can run it off directly off the solar, Or you can put mini inverters on the back of each solar panel, monitor the AC current, use the AC current for some other use if the heat pump's not working. The main focus, I guess, we get back to energy usage. You get right back to human comfort again. And if human comfort is the main criteria to curb energy usage, you have to start with the building design. It's got to come from the building design. You got to start with the shell, whether it's a rigid building or a flexible tent or whatever the case may be. You've got to stop the heat at the source, at the shell of the building. Our experience over the years in building full-size homes and even supportable buildings is such that when you do this, you accomplish several things. The comfort goes up phenomenally. It's in multitudes of comparison to conventional built homes. Things we've done in Hawaii, the tropics, and the Virgin Islands, homeowners be able to turn their air conditioning off completely and not use any air conditioning at all for cooling, and just with their products wrapped around the house and put in the attic. Simple solutions, and very low cost solutions. I guess the basis of what we focus on is not the resistance of heat flow, which is the R factor. What we focus on is changing the direction of heat, and the products we develop do that very effectively. Keeps heat in the wintertime, and keeps heat out in the summertime. So it's like if you were to put it in layman's terms, you're basically thinking of a flexible thermostat, and be it a tent, or an outpost, and whatever. And the other benefit is the Faraday protection. It's we just learned recently. I had this product in my own house, and I'm unable to dial a cell phone in my house since I cleared my house. But the benefit of that is on the military side, if you have a building, a shell, a vehicle that's lined with this material, the protection, the Faraday protection is just phenomenal. Your sensitive equipment, as I've been watching slide after slide of advanced tactical military electronic components be made available. These are all sensitive to electromagnetic bursts or outside source of disruption. These were stored in the product we developed. It's the ultimate protection. You can put it in a vehicle, you can put it in a building, you can put it in boxes, whatever. I have some samples out here later on if you can talk to me about that. I can show them to you. Next slide, please. This is the water condenser. I don't have a picture of the unit. There's a mock-up out there. There's a picture of the actual unit on the easel out there. This is it's a distilled water, so you're getting pure water out of the air, and again, only uses 51 watts. Next slide, please. Also, out in the parking lot, we've got a 150 watt German imported fan with ball bearings. It's totally maintenance-free. What you see on the parking lot out there is a 3-year-old system that's been running every day in the sun. No maintenance, and it's our beta system, so we've been testing it. It runs at 225 watts of power for the mister and for the fan. It's totally standalone. You can do a small area, 600, 800 square feet, misted all day long with water. A very, very small amount of water in that end. And eliminate air conditioning completely in some applications, whether it be a laundry pod or a latrine or a mess hall or whatever. In a dry environment like at Afghanistan, if it's anything like Arizona, then it's just the perfect fit. Very low maintenance, very low, no maintenance actually at all, and it's just the sun comes up, turns on, creates a pleasant atmosphere, and shuts off when the sun goes down. Next question. Next slide, please. This is the product we developed about 8 years ago called thermal control membrane. It shows in a residential building that's put in any kind of building. This is shown here is 20 inches wide. It's 3-layer stick, so it's impervious to dust, gravity, time, temperature. It lasts forever. Once it's installed, it never changes. You're looking at a product about 1/8 inch thick, so a roll 4 feet wide and 2 feet in diameter. Will cover about 20,000 square feet, so you can get a huge amount of product out of one roll. So it's very lightweight, and the effects are absolutely immediate. You put this in a building, and it's like someone turned a heat switch off. You can, takes very little education to learn how to use it. This can go on exterior walls and go in the attics, and in vehicles, my vehicles are all aligned with it, and I drive here in Arizona every day, and it's like a heat switch which is shut off. It's an amazing product. Let's see, this is also the same product that's used for Faraday protection. Comes in 26 inches wide, 4 feet wide, 52 inches wide, and a variety of coatings. So you can have a laminate on the outside, they have a camel color, black, white, pretty much any color you want on the one side. It won't affect the performance. The working surfaces of this product are inside the product. There are multiple layers separated by proprietary mesh system we developed using infrared cameras. We see reductions in homes, 35 to 50% savings. One of the biggest things we're seeing is that the peak demand, which is something that everyone's got to deal with when you're doing the air conditioning, anytime between 11 o'clock and 2 o'clock, 3 o'clock in the afternoon, 4 o'clock, 5 o'clock, depending on the location, you have a large amount of buildings all need the power at the same time. If you can keep the heat from coming in those buildings, two things happen immediately. Comfort goes up, and your demand and consumption go down exponentially. It's an immediate benefit. Next slide, please. It was tested in Australia. Radiant barriers are very prevalent in Australia, and before any of them can be approved or tested, they have to have emissivity values ready. Radiant barriers don't have an R factor, they have emissivity values. And typically they emit at anywhere between 0.10 and 0.08. Ours was the TCM was tested multiple layered. TCM6 has six reflective surfaces. They couldn't get a reading on TCM6. They had to remove one of the layers, and on surface 2 of the second layer, they got an emissivity of 0.02. They couldn't even read the third layer. The machine wouldn't even read it. So I think that's why it has such a great Faraday protection, because the multiple layers of low emissivity surfaces facing each other completely block almost every aspect of electromagnetic, from light to heat to infrared to electromagnetic. Next slide, please. Okay. Again, our background goes all different. I've been working in tropics and deserts, and I'm working in the frigid Midwest. We have climate-specific products for all applications in all areas. Next slide, please. Again, climate-specific products is something that we've coined a couple of years ago. Our products have been tested by utility companies, universities, and ASTM testing by geoscience. And a lot of tests you'll see are in test boxes or in test cells. We prefer to do full-scale, full-size testing, so we get an accurate idea of what's going on inside. I think it's the last one. Next slide, please. Yeah, that's pretty much. Any questions?
Any questions, Brad? Well, thank you, Brad.
Thank
Let's
you.
give Brad a applause. Do we have a presentation? No. Okay. So, well, first of all, I'd like to thank all of you for coming and staying through the second day, and also to Bill Garland and the rest of the rep staff for arranging all the speakers and doing what I call is the PC side of the legwork to make this workshop happen. So I'm very thankful to Bill and to others who made this possible. We thought we'd like to use the rest of the time to get some of your feedback on the workshop. Any ideas you might have for future gatherings, or any other feedback you might have. So, Bill, you want to say any comments?
So, the vision was a better exchange. I think we had some great exchanges. We want more exchange. And maybe the thought of doing this a year from now is probably too long in waiting, and we probably want action to come out of it. I think there's been some comments about what a great